And once again, my name is Piotr Wawrzyniak. I'm from Poland, from Orange Polska, from R&D center of the largest telco operator in Poland. And I will present you the way that we extended Apache Flink with the machine learning methods from the other Apache project, the Apache Samoa. That is still incubating project, but very promising and offering a large number of stream-oriented methods for machine learning. So I'll tell you about the motivation and goals for us. Give you a short overview of the Apache Samoa itself, the extensions that we had to implement for Samoa to make all this integration works, the idea of the integration, the shortcuts from the implementation, mostly for the demo, and then I will show you the live demo how it works, and then of course sum up everything. So the motivation is simple. There's a growing volume of the data that are produced continuously by the various systems, and we need the effective means to process this data. By processing, I mean the processing that can be done with Flink CEP, for example, or with just the stream processing offered by Flink. But also, we would like to use the artificial intelligence tools or the machine learning tools, the other words, to automatically extract the knowledge that is somehow hidden in the data. Particularly in telco business, some of the data streams have to be processed in truly stream manner, so without any checkpointing, intermediate storage, etc., because this is simply not allowed by the law. It's illegal to store some data. Even if you store them internally in the secure network, it's still illegal. You have to, if you want to process them, you have to do it on the fly. Without any storage. And there's no such methods, or there was no such method in Flink machine learning library when we were starting our project, or it was being developed. Now there are a few methods in Flink ML, but still the Apache Samoa project provides a variety of such methods. It also provides the methods from the MOA project, MOE project, that is the previous project of the same team, actually. So all of that leads us to the Samoa project. This is the platform for mining big data stream. It's scalable, advanced, massive online analysis. This is the shortcut of Samoa. It is distributed stream machine learning framework that provides with some kind of abstraction over the different stream processing engines. It can run on, it doesn't provide the distributed stream processing engine itself, but on contrary, it can be executed on top of different frameworks, like, for example, like Flink, because Samoa can be run on Flink, on top of Flink. So it allows you to implement or to focus on the implementation of the machine learning methods, not dealing with the complexity of the stream processing. So it's you don't need to deal with Storm, Flink, or any other tool that would be maybe developed in the future. You just develop your code in Samoa, and Samoa translates it for you to the underlying distributed stream processing engine. So that's the main advantage of the Samoa project. As I mentioned, it includes also the support for Apache Flink as the distributed stream processing engine. However, the connector for Flink is developed for the old version of Flink, and as far as I know, it doesn't work with the most recent release of Flink. So I hope that would get updated by the authors. So again, this is the idea of Samoa. So you develop your machine learning method, your chain within Samoa, and this is then translated to different stream processing. Actually, this graphic is pretty old, so we have S4 and Samza, the tools that I think are not so well developed and maintained these days, but Storm is still popular. Samoa provides its own API. It's based on two items. One item is processor, and this is where you do your computations. And you connect the processors with streams. That's the very simple pattern. And each of your machine learning model has to be built with the use of processors. And stream processing item is a kind of abstraction of a processor that is used internally by Samoa. So when we in Orange started the investigation of Samoa, it was lacking certain features that we needed to make it more production ready, because Samoa at this time was and still is very university and scientifically oriented, I would call it this way. So it's not the system purely for production uses, but rather for experimental, maybe a prototyping, but also not so much, rather to examine the data or to verify the methods or new methods on the data sets, rather than going into production and actually providing the results to other systems. So for example, it was lacking any connectors to the outside world, despite the writing data to the file. So writing to a file is not a good connector to external systems. That's why we decided that we will develop the Kafka connectors, so the components to fetch the data from Kafka and put them into Samoa to perform machine learning, and also a component that would allow to push the output from Samoa, so the predictions, to the external system. And we decided that Kafka would be the best option, as it provides a variety of connectors on both sides, so we can produce the data to Kafka from a number of tools and also read the data from Kafka in a lot of them. Also, we developed the extension that allows you to save individual predictions to a file, because before that, it was only possible to save statistical information, not the one by one the predictions for the future use. So we also extended that. There are all three ongoing works that are not yet published or submitted for inclusion in Samoa. So it's the JSON and Avro serializers and deserializers. So components that would allow you to read and write the objects of Samoa, so the instances basically, because that's the name of the object, using JSON and Avro serialization. And some minor modifications in the ML algorithm. So we discovered that some of the algorithms have errors, and we need to modify them to make them production ready. And also we developed the task-based Kafka component, because Samoa also focused the pattern of tasks. So you can define a task and then run this task in Samoa. So we also developed some components that simplifies the use of Kafka in existing tasks or predefined tasks of Samoa. So now about the integration of Samoa and Flink. Basically, you can imagine there are two ways of doing that. The first one, shown here, is that you just take the code of machine learning methods from Samoa API, from Samoa project, and you implement that or re-implement that in Flink, or you create an abstraction over that in Flink. So you can use that simply in the Flink processing chain. The other option is that you run your job on Flink, do the data pre-processing, stream joining, etc. Basically, you prepare the data for machine learning here at this part. You'd send them through Kafka to Apache Samoa, which is then independently operating. So it is independent instance on JVM. It can run on different machines, etc. Samoa does the machine learning, so it predicts the value of classes that you want, and then output the results back to Flink, so you can further process them, join to other streams, save to HDFS, whatever you want. Of course, both of these approaches has its advantages and disadvantages. So the code-based integration, so the first option, you are sure that the machine learning is done within Flink, so with all the features of Flink, like exactly one semantic, etc. However, you would need probably to rewrite or create some abstraction over Samoa code in your Flink code. And taking into account that Samoa is still incubating project, this API may change, and this method implementation may also change in time. So it means you need to maintain your code if you want to follow the most recent changes of Samoa. Also, you are limited to the methods that you will, that one will implement or will create the abstraction over them. And finally, what is the most important, there is a parallelism issue. So some methods, from the variety of methods in Samoa, they can run only with parallelism set to 1, so basically in one instance of model. They are not parallelizable, they are not scalable that way. So it would mean that if you implement them in Flink, you would also probably need to set your parallelism in all your Flink job to 1, which is not the best option as we know. On contrary, the integration using Kafka between Samoa and Samoa as the separate instance, it allows you to separate the machine learning and the pre- and post-processing of the data. So you can run Flink with the parallelism you want or you need, and then even use the methods that are single-threaded, and then again use the post-processing with a parallelism you want. So that's the advantage. You can take Samoa just out of the box without any modifications. Just download the code or build the code, and it's enough. You just need to import or reference Samoa API in your project to create the objects for Samoa, so to send them to Samoa for machine learning. But the objects are simple; they're just the arrays of doubles with some minor features. The disadvantage, of course, is the communication cost, because we need to use Kafka, so we have some delay. We need to transmit the data, possibly to other servers, to other machines by the network. But we also get the additional buffer if the machine learning performs slower than data producing or data processing, which can be useful in some cases. And as I mentioned, we can use different parallelism settings for Flink and for machine learning for Samoa. And in particular, we can use those machine learning methods that are not parallel. So the one that comes from MOA project, for example. So in Orange, we decided to follow this pattern. So we basically, that's why we developed this Kafka-related components, because we just discussed and we just came to conclusion that this should be simpler, and also, taking into account the evolution of Samoa, it's safer. It doesn't require so huge code maintenance in the future, or will not require so, because Samoa is independent here. So for the demo, I will show you shortly. The most left side of Flink is pretty simple. We just, there's a custom source function that we created that reads the data from ARF file. So ARF file is the special file that was created, that was used in Weka project, and is also used in MOA and Samoa. And this is particularly focused on saving the data for machine learning purposes. We just serialize this data to JSON and send them to Kafka. Pretty simple. Here we don't, of course you can imagine a much larger preprocessing here, so joining a stream, etc. But finally you need to create the object name instance content event. This is from Samoa API. And this object has to be transmitted to Samoa in order to be further processed for machine learning. To get the results, we also consume them from Kafka, and for the demo, we'll just save them to a file because we don't need any further processing. For the demo, we will use the frequential evaluation task. So interleave, test, then train evolution of the model. So as you can see here, we have the source of the data, a classifier, and then the evaluator. And a classifier first takes the single instance of the data, first to test the model, and then to train it. So the model gets updated with every instance of the data. So every new instance, in fact, has a new model with a bit different features. And as the algorithm is designed in the way that the model gets better with every instance, or should get better with every update. So the accuracy of the predictions should increase over time. And the evaluator, the basic evaluator here, that simply evaluates the performance of this classifier over time. This is the task that Samoa will run. However, we needed to extend this predefined task of Samoa with new parameters, basically to output the data from that, because as I told you, by default it was just saving the evaluation results, and we still have this option, but we added an option to send the individual predictions to Kafka, so we can read them in Apache Flink. Also, we had to implement the stream to learn from. So this is the Kafka stream, the one that uses Kafka connectors, so the Kafka and transport store, the component that is already included in Kafka. That was developed by our team. So it fetches the data from Apache Kafka, and it provides the conformity with the stream source pattern that is used across the tasks in Samoa. So it can be used in multiple tasks just by replacing the source stream. Its parameters are, of course, the broker topic and timeout tab. That's the simplest way possible. And by default, we have JSON serialization used here. So all the data through Kafka are exchanged using JSON serialization. The demo is based on the Airline's dataset. This dataset contains the information about the flights from the United States, and the task is to predict whether the flight would be delayed or not. It's based on the information of the scheduled departures. So how the departure time affects the fact that the flight would be delayed. As I mentioned, we will read this file using the custom source that uses the components from Samoa, actually, because it was not implemented from scratch. We used some components from Samoa API. For classification task, we will use a vertical halving tree. This is the classifier that is distributed, so it can be run with parallelism you want. And it utilizes vertical parallelism on top of the very fast decision trees. You can read more about that on Samoa project page. There's a very nice tutorial on that with explanation on how this classifier is built and all the maths that are behind them. Of course, this modified frequential evaluation task will be used, and we'll store the results in a text file. So now let me go to the demo. Okay, sorry for a break. Basically, maybe I will also show you just a minute, the source function of Flink, so the code for Flink. It's basically two classes. This is the source function. So it uses the class rfloader from the Apache Samoa project, and this reads the instances from file one after another. The instance class or the instance object is the key object used in classification or in machine learning models of Apache Samoa, and that's all basically. It also retrieves and ensures that each instance has its description. That's the huge communication cost, actually, because with each instance of data, we send a description of full data set. But this provides us the stateless processing. We could send it with only the first instance, for example, but then it would be a bit tricky whether we get this first instance as the first one or not. And so we decided that each instance will actually have the description of the data set. which I think I can also try to show. So that's the data set, that's the attributes we have here. So there is the airline code, the flight number, the airport where the flight started and the airport where the flight goes to, the day of week from 1 to 7, time, it's the hour of flight, its length, and whether the flight was delayed or not. It's just binary, or 0, 1, 0, not delayed, 1, delayed. And that would be the prediction. So we have already Flink already started. We may try to start Samoa first. So we start the frequential evaluation task. It connects to Kafka with you can see the output from Kafka connectors. We can also submit the Flink job that reads the data from file and send to a specific topic. And I hope everything is started. Yeah. I missed something or not? Huh? Okay, once again. No, the topic is correct. Okay, yeah, now it started. So the output here is with each instance being read and also the accuracy of the model. So you can see this is changing. We can see, yeah, that's the problem with vertical halving tree. That's the error I mentioned. We need to submit the patch for that because it's the issue with. Sorry about that. So we can see the results. That's the output from the Apache Samoa, sent to Flink and then saved to a file with the votes of the tree. You may also see that the class votes or the votes of tree, the structure of tree was changing over time, so it was evolving. Also, we can see the output from Samoa with the prediction accuracy. This is the value here in percentage. So we can see that it's growing and sometimes it's decreasing. So not always the decision that the algorithm makes are right, but in general, in the longer time, the accuracy reaches about 80%. Because sometimes you don't follow this null pointer exception here. It depends on the random value it is initialized. So that's unfortunately that's the error in Samoa. So basically, each 10 instances we got the summary, and so that's the integration we made in the project. I think I cannot tell much details about this project because it's a bit confidential, but it's related to the 5G and IoT networks, basically. So we plan to make it, our goal is to develop tools that are ready to be implemented in the production, not production ready because it's prototype, but that can be easily transformed into production. That's why we used Kafka and this integration pattern because that's our goal, to create the system that can move into production. The advantage is, as I mentioned, the independent tuning or changing the machine learning. So we can change vertical halving tree to another algorithm that performs maybe with a bit lower accuracy, but can be faster, for example, because there's always a trade-off or usually a trade-off between the accuracy and the time needed for classification. So if we need a fast model, we can use something simpler than vertical half-gene trees. Also, we can set a different parallelism, as I mentioned. That's the advantage, because you can use a bunch of methods from MOA project that is present in Samoa. And of course, this communication overhead, especially that we are now making the whole processing stateless, which means we are sending the dataset description with each instance. That's something we are going to work to exclude that limitation in the future. And of course, the installation of Apache Samoa as the separate product is required in the big data stack, which might be difficult in secured environments, for example, or in in production environments that is maintained by different teams or another team. I would also say that it's not my alone work. So we are working in a team of 5 people. 4 of us are from Poland, and our colleague from France, Madhu, is based in France. He is the supervisor of this work, and 4 of us, we all were contributing to Samoa. So thank you for your attention.
Some question?
Thank you for your talk. It was really interesting. But I didn't quite understand what you mean you use Samoa. Like, what I understand Samoa is that it basically implements a bunch of machine learning algorithms and then uses a streaming engine to run them. Did I understand that?
Yes, it's
correctly.
Yes, that's true. That's the goal of Samoa. But they also the way it operates makes it possible also to run it locally, as I did in the demo. So you can. One of the processing engine is the local JVM. In fact,
okay.
That's how the Samoa is implemented. And then you have parallelism set to 1, so you can use all the methods. If you use stream processing engines like Flink, then probably the methods that are not parallelized, so that needs a single instance, they will not work or they will fail in this approach.
Okay, so the Samoa part is not distributed in your setting?
Yes, in our setting it is not distributed, because we wanted to verify or to examine the larger number of ML methods, of machine learning methods.
So do you do that only for debugging, or is it future work for you to push that into a distributed setting?
That's, I would say that's both. So we are prototyping some solutions now on the data that we have, using the single parallelism, because we can verify whether the methods will be good or not for our task. And when we select some of the methods, actually now my colleagues are working on parallelizing one of the methods, because it is very promising to one of the tasks that we have in.
Okay, one last question.
Okay.
When you already looked into that, did you also think about synchronizing models in a distributed setting? For example, when we talk about clue stream,
yes, that's well, we were thinking about that, but truly speaking, we don't have enough time for that. Okay. So we have some boundaries of the project that we cannot exceed. So that was the life trade-off. Let's say.
Okay.
So
thank you.
Okay, thank you.
Do we have any? Okay, cool talk. But I have a note. You said you're using Samoa right now as on a single machine. You don't actually take advantage of what Samoa can offer.
Yes,
because the main idea
in that sense, yes.
Yeah, because Samoa was designed, in fact, to actually parallelize models.
Yeah, that's
and
right.
That's the point, because, for example, vertical Hofstadter trees, they are designed for distributed processing. And when you run it on a single machine right now, How
Yeah,
do you handle
that's-
growth? For example, because you have to grow the trees, because by definition it induces the trees.
Yeah.
How do you handle that? You set bounds, because right now if you want to benchmark or add new algorithms and so on, you have to put some bounds on having a parallelism one. Yeah.
Yeah, that's right. So, well, for the demo, it was run here. So we actually use the two instances of Samoa. For the methods from MOA that needs to operate in a parallelism one, we run basically the Samoa in local mode, so on local JVM. But we also use that on the top of Storm. So then we have the parallel processing for those methods that are implemented directly in Samoa, so they offer parallelism. But this is what we do in our, everyday job in the project. So not for that demo as of now.
Cool. Thank you.
So yeah, I know that the running everything on local mode would be crazy and wouldn't make sense, in fact, in some of the methods, because we would be more limited by the, yeah, that's right.
Do we have
Again,
any other question? Okay, let's thank our speaker.
Thank you.